Alright guys, Elmer the Exponential Elephant here, talking to you about more multiplication properties of exponents. Now here's a question. How do you stop an elephant from charging? Unplug him.
Okay, first thing we're going to do is review exponents. So again, an exponent, we have something raised to a power. Now that something is called your base, the power is called your exponent. The exponent tells you how many times to multiply the base by itself. So 4 to the third power, we're multiplying 4 times itself 3 times in order to get 64. Next thing we're going to do is review scientific notation. So that's a method of writing really large and really small numbers. If you want to write a number in scientific notation, it's got to be in the form a times 10 to the nth power, where a is between 1 and 10. It can equal 1, but it can't equal 10. And n has to be an integer. So if you are converting a really big number, like 5 million, into scientific notation, n, your exponent, is going to be a positive integer. If you're converting a really small number, like 0.00008, into scientific notation, then n, your exponent, is going to be a negative integer. Let's go ahead and review multiplying powers with the same base. So if you want to multiply two things that have the same base, what you want to do is add the exponents together. So a to the x times a to the y is actually equal to a to the x plus y power. New for this lesson, we're going to talk about raising a power to a power. So here, it's different than last time, right? We have a to the x power, all raised to the y power. Now, when you have a power raised to a power, what you want to do is multiply those two exponents this time. So if we have a to the x all raised to the y, that's going to equal a to the x times y power.
Why are elephants bad dancers? Because they have 2 left feet. Example time.
Example 1 says simplify each expression. So we have x to the third all raised to the fourth. So what we want to do is, since it's a power to a power, we multiply those two numbers together and we end up getting x to the 12th. For part B, again, we have a power to a power. So in order to simplify this, m to the 6th all raised to the negative third, we multiply 6 times negative 3 and we get m to the negative 18. Now since it says simplify each expression, we can't leave our answer with the negative exponent. So we go ahead and take this m to the negative 18th, move it to the opposite side of the fraction bar, and since there's nothing left on top, you just write a 1. So it's going to be 1 over m to the positive 18th. Remember, when you move it, it becomes a positive exponent in the denominator. For part C, this actually requires order of operations, whether you believe it or not. So we have z to the 8th all raised to the 0 power times z to the 5th. So we can't multiply these two together first because we have to take care of the exponents first, according to order of operations. So z to the 8th raised to the 0 power, you have a power to a power, so you multiply these two numbers together. What's 8 times 0? That's 0. So we end up getting z to the 0 power times z to the 5th. Now, what we can do is multiply these two together. So when they're like bases, you add the exponents together. What's 0 plus 5? That's going to be 5. So we end up getting z to the 5th. You could have also just said z to the 0 turns into 1, and then 1 times z to the 5th is z to the 5th. For part D, we have t squared all raised to the negative 2nd power times t to the 3rd all raised to the negative 5th power. So we're going to take care of these exponents first, and then we'll multiply the t's together. So t squared all raised to the negative 2nd power. What's 2 times negative 2? That's going to be t to the negative 4th over here. And then t cubed raised to the negative 5th power. What's 3 times negative 5? That's going to be negative 15. So we end up getting t to the negative 4th times t to the negative 15th. When you multiply these two then together, add the exponents, and you end up getting t to the negative 19. Lastly, since we want to simplify, we can't have a negative exponent, so we move this to the opposite side of the fraction bar, and you end up getting 1 over t to the 19th.
Did you know elephants can grow up to 11 feet? Most only have 4 though. You try.
Okay, so here, again, we have a power to a power. So anytime you have something raised to a power that's also raised to a power, you multiply those exponents together. So what's 2 times negative 7? That's negative 14. Now, v to the negative 14th, we can't leave our answer with a negative exponent since we're simplifying. So we need to take this v to the negative 14th, move it to the opposite side of the fraction bar, so it becomes 1 over v to the positive 14th. That's how you make a negative exponent positive. Here we have 2 to the negative 1st power, all raised to the negative 3rd power. So anytime you have a power to a power, you multiply those exponents together. So you end up getting negative 1 times negative 3 is positive 3. So we get 2 to the 3rd power. And since we're simplifying, right, this isn't a variable, so we could actually do this. What's 2 to the 3rd power? That's 2 times 2 times 2. So what's 2 times 2? That's 4 times 2 is 8. Here, we have c to the 5th raised to the 2nd, and then d to the 8th raised to the negative 4th. So what we want to do is take care of those exponents first. So c to the 5th raised to the 2nd, we multiply since it's a power to a power, and you end up getting c to the 10th. Here you have d to the 8 raised to the negative 4. So again, power to a power, you multiply. 8 times negative 4 gives you negative 32. Lastly, since we're simplifying this, we can't have a negative exponent. So we take this guy and we have to move d to the negative 32 to the denominator to make it a positive 32 power. And you end up getting c to the 10th over d to the positive 32. Lastly here, we have p squared raised to the negative first, raised to the third. So we start with our innermost exponent. So we go p squared raised to the negative first. So a power to a power, we multiply those two together. So what's 2 times negative 1? That's going to be negative 2. So we end up getting p to the negative 2 to the third power. Now again, power to a power, we multiply. What's negative 2 times 3? That's going to be negative 6. So we get p to the negative 6. Lastly, since we're simplifying, we can't have a negative exponent. So we take this p to the negative 6. We move it to the denominator, make it a positive exponent, so it becomes 1 over p to the positive 6th power. Now we're going to talk about raising a product to a power. So here, to raise a product to a power, we're going to raise each factor to the power and multiply. So here we have a times b to the x, and that is all being raised to the y power. So what you're going to actually do, since it's a power to a power, you're going to multiply the y to the x, but you're also going to, since this is a to the first power technically, you're also going to multiply 1 times y. So you end up getting a to the y times b to the xy. And that's how that works. The y has to distribute to each of the exponents. So example 2 says simplify each expression. So we have 5x cubed all raised to the third power. So since we have a power to a power, we're going to multiply obviously the 3 and the 3, but this is technically 5 to the first power. So it's also going to distribute to the 1 over here, the exponent for your 5. So it becomes 5 to the third times x to the 9th. Now we can simplify this a little further. We know 5 to the third is 5 times 5 times 5, which we know 5 times 5 is 25, times 5 is 125, and you're done. Part B, doing the same thing. So this negative 2, since this whole thing, 12g to the negative 4th, is all being raised to negative 2, we can distribute this negative 2 to each of the exponents. So this negative 2 times the negative 4, and the negative 2 times the exponent for your 12, which is a 1. So you end up getting 12 to the negative 2 times g to the positive 8. Now, because you're simplifying, you can't have a negative exponent, so this 12, in order to make it a positive exponent, has to come to the denominator, so it becomes 12 squared in the denominator. And then lastly, 12 squared, we know, is 144. And you're done. Part C, again, this 2, we're going to distribute it to each of the exponents of our factors. So S has an exponent of 1. Negative 11 has an exponent of 1. And then R has an exponent of 4. So the 2 is going to distribute to the 1, the 4, and then the 1. So we end up getting negative 11 squared times R to the 8th times S to the 2nd, or squared. Now all we have to do is simplify this. So negative 11 squared is negative 11 times negative 11, which is actually going to be equal to positive 121. Lastly, part D, we have 3b to the negative 2nd, all being raised to the third power, and then times a squared b to the 4th, all being raised to the third power. So again, for each of these, we're going to distribute our exponents. So this 3, we distribute to the negative 2 and to the exponent of our 3, which is a 1. So it becomes 3 to the third power times b to the negative 6th power. Here, again, doing the same thing, we take that 3 and we're going to distribute it to the 4 and to the 2. So we end up getting a to the 6th power times b to the 12th power. Now that we've distributed each of those exponents, we've done power to a power, now we can multiply it like bases. So do we have any like bases? Yeah, just the b's, right? So b to the negative 6 times b to the 12th, when you multiply like bases, you just add the exponents together. What's negative 6 plus 12? That's going to be positive 6. So we end up getting 3 cubed, which is 3 times 3 times 3, that's 27, times a to the 6th, times b to the 6th as well. And you're done.
Where do you find elephants? Depends where you left them. You try.
Okay, let's go ahead and simplify these. So this negative third exponent, since you're raising a product to a power, the negative 3 has to go to the 4 and to the exponent of our 2, which is a 1. So this becomes 2 to the negative third power times y to the negative 12th power, because you're multiplying. So 2 to the negative third, we can't leave a negative exponent in our answer, so we take this 2 to the negative third and we move that to the denominator. And the y also has a negative exponent, so that has to come to the denominator as well in order to become a positive exponent. So we end up getting 1 over 2 to the third times y to the 12th. And what is 2 to the third? That's going to actually equal 8. So we get 1 over 8y to the 12th. Here, this 0 has to distribute to the negative 9 and to the exponent of our x, which is a 1. So we end up getting y to the, what's negative 9 times 0? That's 0. And then x to the, and then what's 1 times 0? That's also 0. So we get x to the 0, y to the 0, which actually, again, anything to the 0 power turns into 1. So we end up getting 1 as your answer. Here we have p times the quantity p to the negative 7th, q to the 3rd, all being raised to the negative 2nd power, times q to the negative 3rd. So this requires order of operations. What do we do first? Well, you need to do your exponents first before you multiply anything. So let's take care of this power to a power. So this negative 2nd power, I actually have to distribute to the 3 and to the negative 7. So this becomes p to the 14th times q to the negative 6th. So now that we've done that, we can start simplifying. Let's multiply like bases. So p to the 1st times p to the 14th becomes p to the 15th, because you add those exponents together. And then q to the negative 6 times q to the negative 3rd, we add those exponents together, and we end up getting q to the negative 9th. Now again, since we're simplifying, we can't have a negative exponent in our answer, so we take that q to the negative 9th, we move it to the denominator where it becomes q to the positive 9th, and you're done. Lastly, 4j squared k to the 6th times 2j to the 11th, all raised to the 3rd power, times k to the 5th. So order of operations, we got to take care of our exponents first. We have 2j to the 11th all being raised to the 3rd power. So this 3 has to distribute to the 11 and to the exponent of our 2, which is an invisible 1. So we end up getting j to the 33rd and then 2 to the 3rd power. Now we can simplify this further. The j squared, we can multiply to the j to the 33rd, add those two exponents together, because when you multiply like bases, you add the exponents. What's 33 plus 2? That's 35. And then k to the 6th times k to the 5th, you add those exponents together, you get k to the 11th. And then 4 times 2 to the 3rd, what's 2 to the 3rd? Well, we've done that a couple times, that's 8. So 8 times 4 actually gives you 32, and you're done. Okay, example 3 says complete each equation. So we have m to the 3rd raised to some power is equal to m to the 12th. Well, we learned that anytime you have a power to a power, you multiply those two things together and you end up getting this right here, which is 12. So 3 times what equals 12? Well, that's going to be 4, right? Because 3 times 4 would give you 12. So that's your answer. You could also just take 3, right, divide it into 12, and you get your 4. Here we have x to some power raised to the 5th power has to equal x to the negative 35th power. Now again, power to a power, you multiply those two things together and it should equal negative 35. So what times 5 equals negative 35? You could guess and check, or you could just take negative 35, divide it by 5, and you get your answer here, which is negative 7. Here we have n to the 9th power raised to some power equals 1. Well, you have n to the 9th and it has to equal 1. Well, anything to the 0 power equals 1. We know that. So if you were to raise this whole thing to the 0 power, that should equal 1. And then here we have a times b to the 4th, all being raised to some power has to equal 1 over a squared b to the 8th. Well, notice that this fraction actually flips, right? These come to the denominator and are being raised to the 2nd power, it looks like. So in order to flip it, it would have to be negative. And then in order for this to become a squared and b to the 8th, this would have to be a 2, right? So it should be negative 2 as your exponent here, and you're done.
Why did the elephant rent a moving van? Because it had a really big trunk. You try.
Okay, doing the same thing here. So we have y to the negative 7th power raised to some power is equal to y to the 28th. So what times negative 7 equals 28? All you could do is just take 28, divide it by negative 7, and you get your answer, which is negative 4. C to the what power, all raised to the 11th power, equals c to the 11th power. Well, again, these two numbers have to multiply together because a power to a power, you multiply those together to get this guy right here. So 11 times what equals 11? Well, that's 1, and you're done. Here we have 3x to the 4th, y to some power, all raised to the 4th power equals 81x to the 16th power. The question is, what does the exponent of y have to equal? Well, here you can see that this is all being raised to the 4th power, so that makes sense. 3 to the 4th is 81. X to the 4th raised to the 4th, you multiply those together, you get x to the 16th. But y isn't even there, which means y must be 1. So y to what power equals 1? That's the 0 power. So y to the 0 power turns this into 1, and then it doesn't even matter, right? 0 times 4 is still 0, so that's why it's not there. Perfect. Here, 2j k to the 4th, all being raised to some power, equals 1 over 32j to the 5th, k to the 20th. Well, it has to be negative, right? Because we flip the fraction. And what do you multiply 4 by in order to get it to be 20? That's 5. What do you multiply 1 by in order to get it to be 5? That's 5. And then 2 to what power equals 32? That's the 5th. So this should be negative 5 here. And you're done. Now let's talk about raising a number in scientific notation to a power. So to raise a number in scientific notation to a power, raise each part of the number in scientific notation to that power. So we have a times 10 to the nth power, all being raised to the m power. What you're going to do is you're going to take this m and you're going to distribute it to the exponent for your 10 and the exponent for your a. This is technically a to the first, so that's why this becomes a to the m power, 10 to the n times m power, right? Because power to power, you have to multiply those. Then what you're going to have to do is make sure that a to the m we put back into scientific notation. So it has to be between 1 and 10 after you're done. Example 4 says simplify. Write each answer in scientific notation. So we have 3 times 10 to the 5th, all being raised to the 2nd power. So what we want to do is we're going to actually distribute this 2 to the 5, the exponent for your 10, and the exponent for your 3, which is a 1. So this becomes 3 squared times 10 to the, what's 5 times 2? That's 10, so 10 to the 10th. Now what's 3 squared? That's 9, so we simplify that. Because 9 is between 1 and 10, this is our answer, and we're done. For part B, we have 5 times 10 to the 4th, all raised to the 3rd power. So again, we take this 3 that's out here, and since it's a power to a power, we have to multiply those exponents. So it's going to be 3 times the 4. We also have to distribute it to the exponent of our 5, which is a 1. So 3 times 1 is going to give me 3. So it's going to be 5 to the 3rd times 10 to the 12th power. Now, we have to simplify this. 5 to the 3rd is the same as 5 times 5 times 5, which is 125. Now, lastly, our answer has to be in scientific notation. So in order to put 125 in scientific notation, we take our decimal point and we're going to have to move it 2 places to the left in order to make this a number between 1 and 10. So 1.25, that's a number between 1 and 10. And since we moved 2 places to the left, we have to add 2 to our exponent over here. So this becomes 1.25 times 10 to the 14th. Let's start with C. So we have 2 times 10 to the negative 3rd, all raised to the 5th power. So again, this 5 we need to distribute to the negative 3 and to the 1. That's our exponent for 2. So this becomes 2 to the 5th power times 10 to the negative 15th power. Now, again, let's simplify this 2 to the 5th. What's 2 to the 5th? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now, we need to make sure that this is in scientific notation. So this 32, we need to make sure it's between 1 and 10. So we take our decimal point and we move it 1 place to the left. That gives us a number, 3.2, that is between 1 and 10. Now, since we moved it 1 place to the left, we have to add 1 to our exponent. So what's negative 15 plus 1? That's actually mean negative 14 because the negative 15 is negative and the 1 is positive. So this becomes negative 14 and that's your exponent. This is your answer. And then lastly, we have 6.25 times 10 to the 7th, all being raised to the negative 2nd power. So again, this is 6.25 to the 1st power, and this is 10 to the 7th. This negative 2, since it's power to a power, we're going to distribute it to the 7 and to the 1. That's our exponent for the 6.25. So it looks something like this. 6.25 to the negative 2nd power times 10 to the negative 14th. Now, we need to simplify this right here. What is 6.25 to the negative 2nd power? Well, technically, since it's a negative exponent, this becomes 1 over 6.25 to the positive 2nd power. Now, you would need to put that in your calculator, and when you simplify this, 1 over 6.25 squared, you end up getting 1 over 39.0625, which, if you were to divide that, you end up getting 0.0256. Now, again, to put our answer in scientific notation, this number out front has to be between 1 and 10. So we keep moving the decimal point until we get a number that's between 1 and 10. So we move it 2 places to the right this time. Now, when you move 2 places to the right, that means you have to subtract 2 from your exponent for 10. So what's negative 14 minus 2? That's going to be negative 16. So we end up getting 2.56 times 10 to the negative 16.
What's big and gray and has a bunch of horns? An elephant marching band. You try.
Okay, let's knock these out. So again, this is 2 to the 1st power, this is 10 to the 11th. Since it's power to a power, we have to multiply those. So it's going to be 3 times 11 and 3 times the 1 power that we have with the 2. So it becomes 2 to the 3rd times 10 to the 33rd. Now what's 2 to the 3rd? 2 times 2 is 4 times 2 is 8. So it would be 8 times 10 to the 33rd, and you're done. Here, again, this is 8 to the first power, and since we have power to a power, the 4 has to multiply to the -2 and to the first power here. So it becomes 8 to the 4th times 10 to the -8. Now, what is 8 to the 4th power? That's 8 times 8 times 8 times 8. That's going to be 4,096. Now, we need to put our answer in scientific notation, so this number here has to be between 1 and 10. So we take our decimal point and move it 1, 2, 3 places to the left. That gives us 4.096. That's a number between 1 and 10. And when you move 3 places to the left, you have to add 3 to your exponent here. So this becomes 4.096 times 10 to the, what is -8 plus 3? That's going to be -5. And that's your answer. Here, 3.9 to the first, we're going to take this 2 and multiply it to the -12 and to the first power here. So it becomes 3.9 to the second times 10 to the -24th. Now, 3.9 squared, go ahead and square that. That's going to be 15.21. You then take this guy and put it into scientific notation by moving the decimal point over to the left 1 place. Now, when you move to the left 1 place, you have to add 1 to your exponent here. So this becomes 1.521 times 10 to the -23rd. Lastly, this 5 to the first power, you're going to have to take this -2, multiply it to the -6 and to the 1 here. So it'd be 5 to the -2nd times 10 to the +12. Now, what's 5 to the -2nd? Well, since the negative exponent, right, you move it to the denominator. So it becomes 1 over 5 squared, which is 1 over 25. Now, 1 over 25 written as a decimal is 0.04. So we then take that and we have to put it in scientific notation, which means this number has to be between 1 and 10. So we move it 1, 2 places to the right. And when you move the decimal point to the right, however many places you move it to the right, you have to subtract that number from your exponent here. So that's going to be -2. So this becomes 4 times 10 to the 10th. Now let's do our word problem. This says the power generated by a wind turbine depends on the wind speed. The expression 800 V cubed gives the power in watts for a certain wind turbine at wind speed V in meters per second. If the wind speed triples, by what factor does the power generated by the wind turbine increase? Okay, step 1 in the word problem. We're not scared. We can do this. Step 2, let's define our variables. What is the question asking us? By what factor does the power generated by the wind turbine increase? So power generated, that needs to be one of our variables. So we'll say P is the power generated by the wind turbine. We're also given another variable in this problem, the wind speed V in meters per second. So V is going to be the wind speed in meters per second. So now all we have to do is write our equation. So what is our equation here? Well, P, the power generated, is given by this expression right here, right? So we say P is equal to 800 V cubed. So if we know the equation, then what are we plugging in? What do we need to put in here? Well, it says in the question, if the wind speed triples, by what factor does the power generated of the wind turbine increase? So we need to figure out if the wind speed triples, what happens? So we're going to go ahead and instead of having V as our wind speed, we're going to have 3V, the quantity, as our wind speed. That means our wind speed has tripled, right? 3 times V. So now all we have to do is simplify this and we can figure out by what factor the power generated of the wind turbine increases. So we go ahead and cube this, 3V cubed. This is the same as 3 to the first power times V to the first power. So this 3, since it's power to power, we multiply it to the 1 and the 1. So it becomes 3 cubed V cubed. Now, what is 3 cubed? 3 cubed is 3 times 3 times 3, which is 27. Now, we can see that we have 800 times 27 V cubed. Instead of multiplying the 27 and the 800, what I'm going to do is actually use the commutative property of multiplication and just switch these two. Now, why do I do that? Because, notice, 800 V cubed, that is the expression that gives the power in watts for a certain wind turbine. So this is our power, what it normally is. But since we tripled the wind speed, you can see that our power now is 27 times what it normally is. So the answer is, if the wind speed triples, the power generated will increase by a factor of 27. And you're done.